Morning, Jayla, Courtney, Josie.
Good morning.
Y'all doing okay?
Yes. Hello.
Morning. Hope y'all remind your parents that we'll have a gym kit after this.
What's the subject going to be?
We have to keep it math because there's too many specifics in the others to make it fair. You know, that's the only fair way to do it because they would know math and they might not know specifics on the other things. Guess we could do literacy, but I've already got the math up. We could do literacy, I guess. I feel like it's still more fair to do math. Hey, let's see. Graham and Lincoln, Miss Priscilla Orlick said, have you all sent your registration in yet?
We should have. We've just been talking over the integrated math deal still.
Okay.
Trying
All right.
to make a decision.
Okay. Lincoln, are you there? Michaela, are you there?
Yeah.
She sent me a text to remind me that to send your registration in when you can.
What registration?
Registration for 7th grade.
What? I don't know what that is.
Okay, stop. That is. And I know who it is because your microphone's blinking. Let's see, Liam.
What registration? I don't know what that is.
Okay, so your mom got an email about a link for a Google form to register for your 7th grade classes.
Okay. Well,
you can just ask her.
Okay.
And if you need another email about it, she can send another one out.
Okay.
Kiwi, are you there? I don't see him yet. Okay, Michaela, did you hear me? Are you there? You're here. You good? Nathaniel, if you'll ask your mom about the email about registration for 7th grade.
Okay.
Okay. And if you need any of those people I'm mentioning, if you need another email, if you can let me know, and I'll let Miss Priscilla Orlick know. See, Graham, Nathaniel, Michaela, Kimani, Lincoln, and Liam is the other one. Is he on here? Not yet. All right, if you've not joined PD.com, it is BSHNE. All right, let's see here. Me looking for Lincoln. I mean Liam, not here yet. Okay.
Mr. P.
Yes.
My mom said she needs another email because she can't find it.
Okay. I will text Mrs. Priscilla Orlick today and let her know. Thank you. And the registration is basically about related studies and math. Pretty much everything else you don't have a pick on. Yes, somebody started to say something.
Isn't the registration thing also on the MEGS website?
Maybe it is. Is it on there?
Because when we were filling it out with my parents, and then we went back, it took us to the MEGS website. So
Okay. I will look and see, and if so, I will text it to the people who need it. I'm the webmaster of the website, and normally I could answer that, but that part Ms. Priscilla Orlick is doing because she also has permissions to author the website. So I haven't paid any attention to it, to that part. All right, I'm gonna go ahead and hit start. So today we are continuing graphs. So Monday's lesson will be live from Graymar. So I'll be at Graymar in that classroom that we were in for 3 days. So Monday's lesson, I'll be over there packing your bags up. And again, after Monday's lesson or prior to Monday's lesson, I will probably text some of you a picture of your stuff to make sure if there's anything you have a question about that gets in your bag. And your stuff will actually be in a clear trash bag, double bagged, like when you get it. And you will, as I said, you will come next Thursday afternoon will be the pickup time, and you'll get information about that from Dr. Underwood before next Thursday. Sixth grade pickup time is between 1 and 5 p.m. on Thursday, the 21st. We will have our Zoom lesson on Monday, Tuesday, Wednesday, and then Thursday of next week, our Zoom lesson will be our Mr. P Awards. So yes, it's a beautiful day. So I hope that maybe that's part of what's filling up your bucket. If you can go ahead and fill out that slide. So Josie, you said Florida's filling up your bucket. Are you going to Florida?
Yes.
When are you going?
For Memorial Day, we have a tiny house down there.
Awesome.
So we're just going to stay there.
Yeah, that's great. So a week from now. You realize this time next week is summer vacation. Not like we're all not already at home. So my wish would be that we could actually get to be in person together, but eventually. And like I said, as soon as it's safe to do it, we will have a get together. And remember, the movie Scoob starts today, and whenever school's back in real school, I'll do an after school time that we'll have treats and watch the movie on my TV because I'll buy it today to watch. Because apparently it's when he's how Shaggy finds Scooby on the pier, and they share a bunch of gross food together or a sandwich or whatever, and it's the story of how they get together. All right, so moving on to see if anybody else has got something awesome in their bucket. Going outside, Permita, that's where I am, and I stay out here as much as possible. So got some things done already, meaning being productive. That's always a great thing. And I bet, Nathaniel, that yours is going to say your dog, and it sure does, doesn't it? Some people got swimming down. I wonder who wrote E.T. and Jeff. Permita, did you write that? Oh, no, that was Jayla, wasn't it? Jayla, you wrote that? E.T. and Jeff, fill your bucket. Right?
E.T. is evil.
All right. So on this slide, this is a little different. I need you to respond to question 1, 2, and 3. So let me make sure what that is. The registration, if you are one of the ones I mentioned that you need that information sent. So if you'll put on the slide, number 1, yes, I need that. Number 2, yes or no, did you fill out the tech task about Mr. P Awards? It was, and if you didn't, you can still go back on the techtask.net website and click on that day. It was last Wednesday, I think. Number 3 is very important because you are going to get 4th 9 weeks report cards mailed to you. So please make sure that you have finished doing your work. It's not about the grade, it's about completing it. So please make sure if you're behind that you catch up on your tech tasks, on your ed puzzles, especially your ed puzzles. If you didn't finish all of the Newzilla articles, that's one thing, but the brain pops and the ed puzzles have content that you need to make sure you've done. So if you're behind, please focus on getting your ed puzzles and your brain pops finished so that I know you got the information. And again, because you will get a fourth 9 weeks for the end of year report card mailed to you after week after next, I think. So just let me know on the text if you will just let me know yes or no on those things.
Are our yearbooks going to be mailed to us too?
So I don't know the answer. I think they will be picked up at the school, but it won't be until June because of COVID-19, the yearbook company got shut down and they couldn't finish printing them. And so they've just now reopened, so they're not finished. Now, they were finished on our part on time, but the printing company couldn't make them. So they're not here yet. So Miss Holloway will be sending out information about how to get those when they arrive. So it'll probably be that you come by Graymar and pick them up, or if you can't, I don't know, they'll probably mail it to you if you can't come. But that's all I know, but they'll let you know. All right, everybody good on this? All right. I'm taking a snapshot of the responses just to be safe. All right, next slide. So we talked about the 5 kinds of graphs. We're going to talk about line graphs again today, start histograms today, and then finish up next week with box and whisker and finish histograms next week as well. So if you will find the red dot, if you will put the red dot beside the kind of graph that would be used if you were looking at your profits in your business, which graph would be used? And I'm going to take a picture of who's in the Zoom real quickly. Got some people not here today. All right, so you got the red dot beside that graph. Okay, next, if you will move the orange dot, which is the graph that would be the graph we would use if we surveyed the class for your favorite ice cream flavor. Which graph would we start with? So orange goes there, which kind of looks yellow on the phone, but orange on the computer. All right. So let's say we got everybody's data for the favorite ice cream flavor, and then we wanted to kind of look at that as the whole group. What graph would be the next graph to use to look at it as a whole group?
Gray dot?
Gray dot. Yes, gray dot for that. All right, green dot. Green dot. Let's say I wanted to know so we took a test and I wanted to know who scored in the top part of the class. Which graph would I use for that? I want to know who were in the top section of the class. Which dot would I use? Use the green dot for that. And last but not least, let's say that we had that same test and we wanted to know how many people made in the 90s? How many made in the 70s? How many made in the 80s? How many made in the 60s? How many made in the 20s? How many made in the 40s? What would I do? What graph would I use there? All right, so yeah, you see that most of us have everything lined up, that if I'm just getting data and I just want to look at it, that's just a bar graph. If I take all the data, count up how many people are in all of it, and then make it as percents of all the whole, that's of course a pie chart, slices of a pie. If I'm looking at profits I earned, the key there is earned over time, so that's got to be a line graph. If I'm looking for the top group of scores, that would be a percentile or a quartile. Quartile, and that would be a box and whisker, but we haven't talked about yet. And then if I just want to know 70s versus 60s versus 40s, that's going to obviously be a histogram. All right. Okay, so next slide. Quick reminder, this is a bar graph. On the screen, can you tell me approximately which two amounts are about the same? Which two animals are the pet that about the same people have? There are none that are exactly, but what would you argue are the two that are about the same?
Either hamster or rabbit or goldfish.
You can write it on the screen.
Okay.
There's more than one answer, right? There's not an exact answer. There's a couple answers you could argue. You definitely wouldn't say cat, dog. Rabbit, cat, nope. Hamster, cat, nope. Goldfish, cat, nope. But would someone care to tell me what they say are the two that are about the same and how they know that?
Well, I would say hamster and rabbit because there's a difference of one between them.
Okay. Yep. There's only a difference of one.
And then there's also
Somebody,
one more.
yeah. Does somebody have a different selection and have a argument for that? Because remember, that's a mathematical practice that you can create an argument and a viable argument and defend it.
I'll say goldfish and hamster.
Okay, do you have the screen up? Let me find yours right here. All right, so you're saying purple and green, that's goldfish and hamster. But you also said hamster and rabbit. So you're saying hamster is kind of close with goldfish and rabbit, right? They're all three generally about the same, around 4 or 5 people, between 4 and 6. So yeah, you could. Does that give you a percent of how many those are? No, but you could get that. And to get that, you would use a circle graph like we talked about yesterday. Would someone care to ask a graph question from this graph that we can answer? Would someone like to ask a question from this graph?
Sure.
Okay, thank you.
If there are 200 responses, how many people voted for strawberry shortcake rolls?
There you go. That should be a mental math that you can write on the screen really quickly. So if 200 people were surveyed on Facebook and we got their answers, how many literally said strawberry shortcake rolls, which I don't even know what those are. Now, just so you know, if I were picking out of there, I'd do the honey bun, I would do the Swiss cake rolls, the chocolate cupcakes for sure. Zebra cakes.
The strawberry shortcake rolls are good.
Are they? I bet they are. My last choice on there would be the Nutty Bars. Oh, fudge brownies. Yeah, for sure. All right, with somebody else. Okay, the answer was what, Graham? How many
The
literal?
answer was 6.
Yeah, and the reason he knows that is because he did 3% times 200, or he just knows 3 is 100, so double it to 6, right? But literally what you do is you would say 3% times 200 people. So what would that number be if there were only 50 people? It wouldn't be there, would it?
Yeah,
It
because
could,
it'd be part of a person.
right. You couldn't have 3% if it were 50 people because there's not a half vote. It would either be 2% or 4%, right? You couldn't do a 3%. Does everybody understand why? Because you don't have a half vote. Depends on the context of what it is. But you can't have a half vote. Let's do one more question. So let's say there are 20 people that voted. 20 people that voted. Which of those would not be possible to have a percent for if 20 people voted? Just write on your screen, which of those would not be possible to be that actual number if only 20 people voted? So here's the first question. If 20 people voted, one literal vote would be what percent? 5? Correct? 5%. So 3%, 2%, 3%, 2%, 5%, those numbers wouldn't be there. We would have only numbers in 5%, right? Does that make sense? That would change it totally if we did that. Okay. Here's another thing I wanted to say about that. How many times have you heard somebody say they're in a group and like say everybody voted for something except one person? They say, well, like 99% of the people voted for that. Why is that wrong to say that? Like
How
say
many
we vote,
people?
go ahead.
How many people voted in it?
Like let's say it's your class. Could you ever say 99% voted for that?
Nope, because unless there were 100 or a multiple of 100 people, it couldn't be 99%.
Correct. So just a little FYI, people do that all the time. They'll say, well, about 95% of everybody agreed to that. Really? Or were you falsely telling that? So yeah, you have to think about that when you're talking about the number of the size. Okay. So tell me something about this graph that truly should be actually done differently. Right on the screen, what's something about this graph? It's okay, but what would make it better? If what were happening on this graph? About the way it's made. That's what I'm talking about. Fred, did you get in?
Yes.
Okay. The code, is it on the screen still?
My stuff cut. I'm gonna look inside the chat, but my stuff cut out, and then I couldn't get back in.
Okay. Well, I'm glad you're here now. Can't find the, oh, BSHNE. It's behind my little Brady Bunch Zoom thing here. All right, so some of you are saying the thing that would need to be different was that it should just be dots. And truly, they shouldn't be connected because you don't do partial push-ups, right, in between days. But it's okay because it's showing you about the rate of the change each day. So the lines are there to give you an idea about how much the drop was or the increase was. But truly, that should be represented as a scatter plot, right? But that it's used that way because you're showing the change. All right, let's look at this graph. What about this graph? Tell me something about this graph that makes the line actually more appropriate. So on this slide, will you write down what makes the lines connected on here more appropriate? Did Liam ever get in? Let's see. I don't see. Is Liam here? Nope. So I'll give you about 30 more seconds to respond. We're going to look at people's responses here. So we still got about 7 people that haven't written their answer yet or finished their answer. Josiah, did you have a question? All right, so I'm gonna 10 more seconds. See James, Melis, Courtney, Josiah, if you'll go ahead and put your answer in. All right, so let's take a moment to look at what some people said. Okay, this person said, okay, they are actually dots. So there are dots on there. This person said that it uses points and also the graph to get it in properly. Okay. Here we say because it's showing the change in temperature and how much it changed. The whole time it's just going down. It's showing you that change of time, temperature over time. This person, the space is more reasonable to see the difference. And there are more dots per the interval of time. I added the word interval of time because they mark the interval of the time. And here we got the temperature is always changing, so it could be a line because the temperature probably doesn't hop around. It probably goes gradually in a slow, steady rise or fall. It doesn't have to be slow and steady. See here. Is this Michaela? There are numbers in between, so it's showing us what the temp is in between the five intervals of 5. This one says it is not linear. That is definitely right. It is not linear. It's non-linear. And showing us that it is non-stop changing because the temperature doesn't stop. It continues to fluctuate. Showing the change with the dots and connecting the dots. And the whole point of connecting the dots is to give you the visual representation of the time change, of the change over time. Okay, so here's the question. What do you suppose this is? Because it doesn't tell you the x-axis. Tell me what you think the x-axis maybe is. I want to point out the y-axis is in Celsius. So if we were literally in school, this would be an exit ticket right now because I'd want you to take what you know about temperature in science, apply it to this graph. So if you'll write that on the screen, what is actually probably this graph about? Because there is a very specific thing that it's about. It's very obvious what it is. You might not figure it out, but that's okay. Once I tell you, you're like, oh, of course that's what it is. Uh-oh, hang on. Okay, let's see here. I see a person who got exactly what it is. All right. So this person said how the temperature changes over time. This person said, which is funny, winter is coming. Notice what this person said. Let's see. That the x-axis is the time and the y-axis is the temperature. Definitely it is. Most of you have said that obviously, and this is the case all the time. The x-axis on a line graph has got to be the time. That's just what it has to be, because the time tells you what the number is on the y, because that's the way graphs work. But this person figured out what this specific data is. And this person says the graph is about boiling water getting cooler. Could this person identify themselves and tell me what told them that's exactly correct, how they know that?
It's me, Graham. The reason why is because 100 degrees Celsius is boiling water.
Yep. So this was someone who put some water on to boil, like a teapot or whatever, and they have done what at 0? What did they do at 0? Graham?
At 0, they freeze.
No, I'm sorry.
Wait.
At 0 time, what happened?
It was still boiling, and then they took it off.
Okay.
And
At the time the graph started, the water was boiling in the pot or kettle, and they turned it off or took it off the eye, right?
correct.
And then over the next 20 minutes, it slowly cooled down till at 20 minutes, it was at about 45 degrees Celsius.
Correct.
And the reason he knew that is because the 100 is what water boils at in Celsius. So in Fahrenheit, what would that number be on the Y? What would that number be on the Y in Fahrenheit? Anybody
Answer,
know?
or do you want someone else to?
Somebody else know? Anybody? Graham, what is it?
212 degrees Fahrenheit.
Correct. If that were a Fahrenheit, that would be 212. Okay. Does that make sense now? The graph should have that written down, but if it didn't, you can completely 100% know that's the answer, because 100 degrees, they stopped it, turned it off, it started cooling down. Anybody have a guess as to why there is one section of the line graph that's a little steeper than any of the others? Could someone who hasn't spoken tell me why, where they notice the line graph is slightly steeper in its drop? Anybody?
Well, it's
Go ahead.
you said it's why it's steeper.
Why is there, where on the graph is it slightly got a little steeper drop?
Well, right, like in between the 100 degrees and about 50 degrees Celsius.
Okay.
That's when it's like the most steep.
Can you see the screen, what I put in the circle, the oval?
Mhm.
Okay, do you all see it's a little steeper right there? So it dropped at a rate, then it was a little faster dropping right here. Here's what you could suppose. It was probably still on, they probably just at 0 minutes, they turned it off, but they didn't take it off the eye. And probably right here is when they took it off the actual eye of the stove and set it over on, like, say, a hot plate. Not, something on the counter on a oven mitt, or whatever you call the thing you take stuff out with, right? And that's probably why it cooled a little quicker here all of a sudden, and then it started cooling less steeply here, right? Can you see also, this is something you'll do in algebra, line of best fit. Look, y'all see this? You see the red I just put on there? What do you notice from minute 7 till about minute 20? Notice from minute 7 till about minute 20.
it's pretty close to linear, but it's
It is
not quite.
very close to linear. That's exactly right. But also, what did you notice from about from about 0 to about 4 or 5? Also pretty linear, right?
Yeah.
Okay. And you notice that this is a thing. The slope right here and the slope right here are not that different. Okay? But the slope here is steeper, right?
Yeah.
Okay, and the reason is because that's very likely where it was actually lifted up off the stove and sat on the counter. That would be, so this is actually a skill you have to do in Integrated Math 1 where you have to interpret a graph. And you always start with line graphs. And if you watch the Ed Puzzles, that was part of one of your Ed Puzzles where you were being asked questions about what was going on in the line graph. So there's how you would analyze that. I'm going to say it really quickly again as we wrap up for today. This is completely, for sure, with no doubt, water that was boiling on a stove. It was turned off as the graph starts. It was most likely lifted off the eye at about minute 4. That's why all of a sudden it rapidly cooled at a higher, faster rate by the slope here. Because it was taken off of the residual heat that was on the stove still, right? Then it continues, it's a little slower right here for a second, and then it seems to cool at a pretty steady rate the rest of the way because it was unbothered. Another option right here would have been that this is the point where they what? Anybody know? What might have also happened right here? Anybody got a guess? Anybody?
I can't.
Maybe they put like a little bit of cold water into it
That's
or
what I-
something.
Okay, let me say there's something else they might have done because generally you don't do that. What do you generally do with a tea kettle?
You turn
what do you?
turn the stove.
Okay, you can clearly see they turned the stove off here, but what do they probably do? Let me make another arrow in a different color. What did they probably do right there?
If they put it in a tea bag, wouldn't it absorb some of the heat?
Or they
And-
just moved the tea kettle to a different spot.
Yeah, but what else might they have done right there?
They take the top.
Oh,
They poured it into another cup.
Okay, that's the moment they poured the water out into their cup. You can't see I'm pouring my cup. All right. The blue arrow there is the moment they poured water out of the tea kettle into their cup to make their tea or whatever. So they turned the stove off, the graph starts. It wasn't for about 4 minutes that they actually poured any water out of the pot. That's why it rapidly cooled right there. And then they sat it most likely on another surface, but could they have still set it back on the stove where it was? You could argue that too because of the fact that over here, this rate over here is about the same as it was up here. So you could also argue that was sat back on the same place. So the red circle is the point at which they poured water out of the kettle. And they may or may not have sat it somewhere else or back on the same place on the stove. All right? All right. So I will say see ya for the math lesson. I will close out the Zoom. I will turn on the Zoom for the parent versus kid final showdown.
Oh yeah.
For in just a moment.
Bye, guys.
Again, this reminder, we will do GIM kits for the ones who want to this summer, once a week if you want. So I'll see you all on the GIM kit in just a minute. All right.
Yeah, bye, guys.
Okay, bye.
See you guys later.
See ya.
Bye.